So what I'm presenting to you today is an expansion of the fourth chapter of my recently concluded PhD project, as mentioned by Fabrizio, the localization of the Avicennan inner senses in the Galenic brain. So in this chapter, I specifically dealt with illustrations of the theory of inner senses in the Arabic tradition. Now, in tracking such illustrations, the diagrams of the brain, so not the entirety of the theory of inner senses, but specifically diagrams of the brain and mainly its ventricles, attracted my attention as image texts that played a role in the diachronic transformation of the concepts of the brain. Now, what do I mean by image texts? For that, I borrow the words of Hamburger. And I quote, so medieval diagrams as paratextual elements combining text and image offer a paradigmatic example of image texts. That is, composite synthetic works or concepts that combine image and text that at the same time designate a problematic gap, a cleavage or rupture in representation. End of quote. Now, as examples of such image texts, the diagrams you see on the slide, all found in manuscript witnesses of al-Mansuri fi at-Tibb by al-Rāzī, about which I will give you more details later, obviously. So all these diagrams were meant to visually represent the same anatomical structure, namely the ventricles of the brain. Now, as you can see, these diagrams, qua image texts, were subject to mouvance, that is, accidental or deliberate changes through scribal practices, just like the text that was hand-copied from one manuscript to another. Now, in this talk today, and in this time that I have with you, apart from discussing some unique illustrations of the brain in the Islamicate tradition, by focusing on these diagrams of the ventricles of the brain, I argue that certain philological questions can be posed to these image texts. For instance, questions pertaining to the familial relationship of the manuscript witnesses. I hope by the end of my talk today, I will at the very least have managed to somewhat make sense, some sort of sense of this visual chaos that you see on this very first slide. To do that, and to make sense of these diverse visual representations of the ventricles of the brain I've just showed you, I will first contextualize the ventricles of the brain within the framework of the theory of inner senses. Why such focus on the ventricles of the brain? And to explain the salience and importance of the ventricles, I will present an overview of the idea of ventricular localization of the faculties of the soul, mainly within the Islamicate tradition, mainly focusing on Avicenna. After a very brief visit to the visual representations of the theory in the Latin tradition, I will discuss in detail two unique instances of the visualization of the brain and its ventricles in the Islamicate tradition. One is an illustration in al-Halabi's Al-Kafi fil Kuhl, which is a work on ophthalmology, and another, a later interpolation in a manuscript witness of Avicenna's philosophical work, Al-Isharat wa Tanbihat. And then for the better part of my presentation today, I will move on to the mini diagrams of the ventricles that I just showed you, which show up in manuscript witnesses of al-Rāzī's Kitab al-Mansuri fi at-Tibb. After a general survey of the manuscript witnesses and the various diagrams they contain, I will discuss the possibility of constructing a stemma codicum based on these paratextual elements. I will then argue for the benefit of thinking in terms of family tree metaphor in the case of such diagrams. And then I will very briefly present some suggestions regarding the indirect witnesses to this work in the Hebrew and Latin traditions and the diagrams that these witnesses also contain. Then I will raise some questions about representing such anatomical diagrams in a critical edition or in any print format. I will then share an instance of possible percolation of visual ideas back to text. So not just text to image, but possibly could there have at some point concepts have traveled back from image to text. And I will obviously conclude looking forward to your comments, thoughts, and questions. Now, the ventricles of the brain have been among the most salient structures in the anatomy of the brain in the medieval Islamicate tradition. One reason for such salience is the status given to them in the framework of the theory of inner senses or cell doctrine. So the theory goes with different names in secondary literature. Now, this illustration you have on the right depicts the Avicennan account of the theory, which is what I would be very briefly going over for you. And then this revolving animation on the left is the ventricular structure as we know them today. So the blue structure within this like revolving brain you see on the left is the ventricular structure from our perspective today. Now, this theory of inner senses postulated that mirroring a set of external senses, a number of internal senses or perceptive faculties of the soul, in turn, perceive, store, and transform the abstracted forms of the sensibles. So, like sense perception is very much Aristotelian in this framework. But then you have these like later developments and later synthesis of several ideas, like Aristotelian, Galenic, and Nemesian ideas coming together as a whole in Avicenna. Now, these faculties of the animal or psychic soul were housed in specific spots in a set of hollows in the brain, that is, the ventricles of the brain. Galen of Pergamon obviously meticulously described the dissection of the four ventricles in his main anatomical works. So, for example, on anatomical procedures, and described their anatomy in his work on the usefulness of the parts of the body. Both of these texts were translated into Arabic and were available to such actors as al-Rāzī and Avicenna in the medieval Islamicate tradition. Now, in my dissertation, I argue that numerous factors contributed to the endurance of this idea of ventricular localization of the faculties of the soul. Like, mainly, why the ventricles of the brain? Why these hollow holes inside the brain and not the matter of the brain, for example, to host these like faculties of the soul? Why these holes? So I do argue that there are several reasons that contributed to this endurance of this idea. And I also argue that the possibility of very easy visual representation of the ventricles of the brain within a manuscript culture could have also been one reason. And that is what I will be focusing on today. But for now, it's important to bear in mind that this three-dimensional ventricular system that you see on the left is a complex structure, and a brief textual representation does not suffice to adequately describe the positioning of the ventricles with regard to one another. Furthermore, both from our perspective today and from that of Galen's, the ventricles are four. They're four in number. There are two ventricles in the front, what we today call lateral ventricles, one in the middle, what now we today call the third ventricle, and one in the back, from today's perspective, the fourth ventricle of the brain. But both in the late antique tradition and within the Arabic Islamicate tradition, it became customary to regard the two front ventricles as one, as they were postulated to fulfill the same function. And this was also mentioned by Avicenna. And this number of ventricles was reduced to three. I will come back to why I'm stressing this point a bit later in the talk. Now, you might have come across visual representations of the theory of inner senses within the medieval Latin tradition, as they're quite abundant. And within this Latin tradition, illustrations generally tended to depict either three holes inside the head, in correspondence with the late antique threefold faculties of the soul, that is imagination, thought, and memory, or five, necessitated by Avicenna's fivefold faculties of the soul that were later received in the Latin tradition, that is common sense, imagery, imaginative faculty, estimation, and memory. Now, such illustrations are quite scarce within the Islamic tradition, but despite the scarcity, I still argue that visual representation of the ventricles was also easily possible using the conventions of illustrating anatomical structures using basic shapes, as I will show. In short, Among the anatomical structures of the brain, the ventricles were exceptionally convenient concepts to engage with for actors involved in processes of textual and visual transfer of knowledge. Actors like al-Rāzī, Avicennan or Ibn Sina, and al-Halabi. Now, I will now discuss two instances of visual representation of the brain and or its ventricles and their corresponding inner senses. The one on the left shows up in a book dedicated to ophthalmology. The author, so Khalifa ibn Abi Hassan al-Halabi, wrote the book Al-Kafi fil Kuhl, that is the sufficient book on ophthalmology, in the year 1256 of the Common Era. The colophon of the manuscript in question, from which you see this illustration on the left, bears the date 967 AH, that is like mid-16th century. There's a much earlier manuscript of the same work in Paris, dated quite to the end of like the 13th century of the Common Era, about 20 years after the composition of the text. So like textually, like the Paris manuscript is quite valuable. However, this Paris manuscript lacks the illustration of our interest, and there is a plain folio in its place. So this illustration you see on the left is unique. So in all the two manuscript witnesses of this work, only this manuscript held in Istanbul holds this illustration. Now, about like a few notes about the manuscript itself. The codex is quite a hefty one. I've been lucky enough to like work with it in person myself in Istanbul. It has full leather binding with really intricate blind tooling. The text is written in clear, not very elegant naskh, so a very technical naskh in black carbon ink. And the titles are in red, and several colors like gold, silver, leaf are used in the illustrations, as you see. There are several endowment seals, which point to Ottoman provenance. There is a physician's seal at some point. Some seals have been scratched off from the title page, and there's an ownership note on the title page. Well, all of these point to the execution of the manuscript in a very skillful manner, and a continued interest in this manuscript throughout its trajectory. The illustration of the eyes and the brain is on folio 12A, and there's a set of illustrations of tools used in ophthalmology across 3 folia, if anyone is interested. This is quite an interesting manuscript. Now, the second instance seen on the right shows up in an early dated manuscript, but as an undated later interpolation. The manuscript itself, so, is a witness to this text, Al-Isharat wa Tanbihat, Pointers and Reminders, which is the last encyclopedic text written by Avicennan on philosophy. This work is written in method of isharat, pointers, so that the knowledge it contained would only be accessible to those worthy of it. The text has a very rich manuscript tradition. Dimitri Gutas lists around like 50 manuscripts, among them a manuscript in Berlin with the serial number 5046, dated to the middle of the 16th century. And that is the manuscript that you see on the right. Now, this manuscript is in no way the earliest dated manuscript of this work, but it is of high interest because it contains this schematic representation of the theory of inner senses. And I will come back to this in a bit. Now, to start with the Istanbul manuscript, the illustration contains several fully decorative elements and makes aesthetic choices in the representation of technical elements. Above the illustration, to fill the space resulting from the placement of the arc that represents the skull in a rectangular frame, there are these 2 beautifully placed like quadrant spandrels. Due to discoloration of the background, only traces of a decorative arabesque pattern are visible. Sorry, why is this going forward? Sorry. Traces of green and red pigment point to the presence of a central palmette, and this illustration, this picture is like to give you an idea of like what the pattern might have looked like. The 2 olfactory bulbs are drawn as droplets in bluish gray, which could have been silver leaf, and they're delineated by a red border. The triangle resulting from the space between the crossing of the optic nerve and the half circle representing the skull is gilded. The pupils, which are depicted as full circles and are not compatible with the perspective of the cross section of the eyes, are gilded. And there are 5 circular decorative elements to balance the composition around the optic chiasm and the eyes, which are gilded and ornate with the floral motif. Furthermore, the illustrator has made deliberate use of different colors to convey information regarding the anatomical structures. For example, the line encompassing the components of the eyes and the cross, labeled as conjunctiva, is executed in red, while the 2 small arcs that denote the corneas are executed in black. More impressive is the case of the optic chiasm and the dura. Now, the outlines of both the skull and the brain are executed as a broad band, and 2 parallel black borders, there are these 2 parallel black borders, the space within which is colored differently. The skull is gray and the brain is executed in yellow. And the yellow of the brain is extended to execute the optic chiasm, emphasizing how the optic nerves are extensions from the brain. And this is an emphasis that already exists in Galen and is taken over in the Islamicate tradition. Now, all this dialogue between the artistic and the technical elements in the illustration and the artistic care in its execution could explain the presence of the artist's signature along the crossing of the optic nerve. Now, Emily Savage Smith has already drawn attention to this signature as the only instance of a signature of the artist showing up in an anatomical illustration in the Arabic tradition. However, I mean, she would read the name differently than I would, but she has drawn attention to this already in secondary literature. Now, generally, the text of the labels neatly follow the orientation of the adjacent lines in the illustration. The illustration has no solid orientation. Some colleagues who might have already seen this illustration in secondary literature might notice that in secondary literature, this illustration is presented in print like upside down. The way you see this on the slide is how the manuscript, how the illustration is actually found in the manuscript itself. So the illustration has no solid orientation. The labels on the diagram are arranged along various axes, and the text in the frame starts on the lower right corner, rotates 270 degrees to arrive back at the starting point. Now, I want to suggest, maybe this is a bit pushing it too far, but I want to suggest that this might serve as a subliminal reminder to the reader of the book, who is accustomed to like horizontal arrangement of material on the text panel, that one needs to apply some spatial intuition and imagination in order to comprehend this illustration and its relation to the actual arrangement of anatomical structures. Now, the illustration is made up of basic shapes, quite basic shapes and straight lines. And this is in line with Emily Savage Smith's description of early anatomical illustrations in the Arabic tradition. According to her, the anatomical illustrations in the Arabic tradition are generally dominated by the presence of geometric forms, highly schematic approach to bodily structures, very comfortable relationship with impossible perspectives. That is to say, the presence of several views and sort of like views and planes at the same time. The general outline of this illustration is made up of, I would argue, a superimposition of 2 common anatomical diagrams in the Arabic tradition, looking back at 2 visual traditions, 2 separate visual traditions. That of diagrams of the visual system on the left and cranial sutures in the center. Now, the diagrams of the visual system portray the layers of the eye using circles. Many of them also represent the crossing of the optic nerves. Illustrations of the cranial sutures also show up frequently in Arabic medical manuscripts, all drawn attention to by Savage Smith. All the sutures of the skull depicted in these common illustrations So you have the coronal, sagittal, squamous, and lambdoid in the back. They're not visible in one and the same view. So here you have at least four views of the skull all pressed on a flat surface. You have the superior, frontal, and two lateral views of the head, all presented on a flat surface. And still, in including the concepts of inner senses and the idea of their embodiment in the ventricles of the brain, the illustration is not only providing several views, but it's also representing several planes at the same time, both above the skull and inside it. And by doing so, the illustration is organizing data in a manner impossible in the text. But still, to be comprehended fully, it still needs to be somehow read alongside the text. And that is why this is an image text, not fully an image, not fully text, somewhere in like a cleavage in between. Now, I would like to show how the producer of the codex or the author of the text has felt the need to address what the image cannot represent on a flat surface. This illustration shows up in chapter 5 after a subheading in red ink reading mention of the anatomy of the brain. Right after this red subheading marking the beginning of the chapter, there's a sentence which describes what this upcoming illustration on the next folio is and what it contains. The sentence is almost exactly repeated in the frame enclosing the illustration, but there's a crucial bit in the text that does not show in the illustration on which I want to stress. So the text reads, this illustration is the shape of the brain and its three ventricles, which are the location of the five inner senses. They are the common sense, called fantasia, and its reservoir, called the formative and the imaginative. And it is in its front ventricle. And in the middle ventricle, the faculties of thought and estimation. And in the rear ventricle, the recall and memorative faculties. Then the source of the layers of the eye, in the substance of the nerve, and the mothers, that is the meninges, and their shape and the shape of the moistures, that is the layers of the eye, and their positionings. And here it comes, to the extent that its execution is possible on the non-spherical surface. End of quote. Now, the text describes clearly what the illustration is meant to do. The phrase marked in bold does not show up in the frame text, as I mentioned, and it has not yet been drawn attention to in recent scholarship on this illustration. However, it is a crucial phrase as it shows an awareness of the impossibility of fully representing cerebral structures on a flat surface. How are then the inner senses and their locations represented in this carefully executed illustration? The majority of the labels on the illustration refer to structures clearly outlined. For example, the olfactory bulbs or the layers of the eye. However, this does not hold true for the labels referring to the localization of the inner senses. These textual labels referring to the ventricles of the brain and the corresponding inner senses are merely mounted on the outline consisting of the sum of the optic system and the skull sutures. And the locations of the three ventricles are thus noted in four labels, and I've translated them into English that you see on this image on the right. And these four labels refer to the faculty localized in each, and I will not go into further detail here. So, next is a descriptive diagram inserted somewhere after the first third of the 10th namat of the second section of Avicennan's al-Isharat wa tanbihat, pointers and reminders, in the vicinity of several pointers and reminders that mention the inner senses. Now, this tab, as you see, so this dome-shaped tab that is cut out and it's inserted into the manuscript, is kept in place using a stub, which is an extension from the tip of this cut-out dome, and it is glued to the next folio. It's glued to folio 143b. Now, interestingly, on the flip side of the diagram, in a different hand from the codex, but similar to the labels on the diagram, a description is given of the brain, its nature and major structures. And I'm reading the English translation of this Arabic passage that you see on the flip side of this like interpolation. The brain is a soft, fatty, rarefied, cold and wet, cone-shaped organ with its base in the front of the head, and that is the cone's vertex in its back. That is the back of the brain. It is made up of membranes and an essential substance accompanied by veins and arteries and cavities full of pneuma. There are 3 ventricles in its length. The biggest of them is the front ventricle, then the rear ventricle, and then the middle ventricle is like a vestibule between the two. End of quote. Now, it's evident how, in a philosophical context, the anatomical knowledge deemed crucial for the reader to have regarding the brain is summarized in this encyclopedic information provided, and this encyclopedic information looks back on an Avicennan formulation. In listing the structures, this flip side of the diagram resembles an opening line in the subchapter dedicated to the anatomy of the brain in the 3rd book of the Canon of Medicine by Avicenna, where he says, I quote, "The brain is divided into a membranous substance and an essential substance and 2 cavities full of pneuma." So this is like the overall conceptualization of the brain. It has a membranous substance, an essential substance, and cavities full of pneuma. Furthermore, apart from likening the brain to a cone, the text is loyal in terminology to the Avicennan account of the anatomy of the brain and presenting the brain as basically a ventricular structure. The diagram itself is quite straightforward. It's an encircled cone executed in red ink and labeled in black letters. The diagram has no concrete orientation, and textual material is arranged along 2 axes in 4 directions. 4 labels around both inside and outside the circle orientate the viewer regarding the spatial arrangement of the represented ventricles, the facial side of the brain, the back side, the crown, the head, and the chin. And the cone itself is divided by 2 parallel lines to 3 spaces representing the 3 ventricles of the brain. And from front to back, the first space houses the common sense and imagery. The middle houses the faculty of disposition and the estimative faculty, and the last space houses memory. So this is basically a schematic representation of the brain inserted in a philosophical work that inherently invites active engagement with the text. And for those interested, the manuscript has extensive marginal notes and engagement notes. It's a very interesting manuscript to take a closer look at. Now, I have covered so far 2 solitary instances of illustrations of the brain and its ventricles in the Islamicate tradition. But what happens when a text accompanied by diagrams is transmitted not by 1 or 2 or 10 manuscripts, but there are many more manuscript witnesses of the same work? Now, that is precisely the case with the popular medical encyclopedia by Abu Bakr Muhammad ibn Zakaria al-Rāzī, whose name was conveniently Latinized as Rāzīs. Now, he was a physician, a philosopher, alchemist, was the head of the hospital in Ray, near contemporary Tehran, before moving to Baghdad. He dedicated one of his major medical works to the then Samanid ruler of Kerman and Khurasan, Mansur ibn Ishaq ibn Asad, hence the name Al-Kitab al-Mansuri, so the book of Mansur on medicine. Considering its convenient size and systematic nature, the work enjoyed great appeal, as shown by the large number of manuscript witnesses and its translation into Latin and Hebrew. This comprehensive yet concise medical encyclopedia is organized in 10 books. In the first book, dealing with the organs of the body, several manuscript witnesses contain mini diagrams of the brain ventricles, chest, trachea. 2 manuscripts have mini diagrams of the hyoid bone. 3, a dubious yet elaborate diagram of the bones. What you see on the slide is my growing database of the manuscript witnesses of this work and the diagrams that they contain. Now, a comprehensive study of all the various diagrams in the manuscript tradition of this work is obviously in order, But in this talk, I focus solely on the mini diagrams of the ventricles of the brain, and that is the rightmost column that you see on the slide. So far, I have tracked 83 manuscript witnesses of the text. I have acquired 49 of them, 20 of which contain the brain ventricles diagram, which I've arranged in this database. Now, these diagrams of my interest are visual representations, but given their size and simplicity, they have most probably been executed by the scribe executing the text, and not a separate illustrator, as was the convention with illustrations, mainly, and especially like scientific and more like scholarly illustrations. Now, as mentioned before, so several post-Galenic traditions went on to count and represent 3 ventricles in the brain, or the head. The diagrams showing up in Kitab al-Mansuri, however, look back to Galen for the number and configuration of the ventricles of the brain. The text of this work by al-Rāzī also reads, I read the English translation, quote, "The brain is not solid, but has hollows. According to Galen, there are 4 hollows, some of them leading to others, called the ventricles of the brain. 2 of them are in the front of the brain, 1 in the middle, and 1 in its back, according to this shape," end of quote. And this is where the diagram shows up in the manuscripts that the diagrams show up. Now, these diagrams that you see on the left, so the top one, Züthoff already brought attention to this, and the bottom one has been discussed by Savage Smith. So these are the only 2 instances that have shown up in secondary literature. Both of them represent a common idea. That is Galen's textual description of the number and positioning of the ventricles using different basic shapes. So basically, the ventricles are 4 in number. The 2 front ventricles are distinguished. The middle and rear ventricles are placed along an axis that ends in the spinal cord. Now, relying on these 2 manuscript witnesses, all this can be quite satisfying for those looking for anatomical truth in a manuscript culture, or those mainly in a rush to find anatomical truth in this tradition. But to drastically complicate the picture, with regard to Mansuri, anatomical truth does not fully overlap with codicological truth. A survey, like a very cursory look at other manuscript witnesses of this work, points to both more elaborate illustrations and simplistic interpretations by scribes that cannot be explained by this scheme that I just showed you. So, for example, how do you explain this cross that you see in the middle? So, as I said, I have this growing database of the manuscript witnesses of Mansuri, and their date, I have their date based on the colophon when present and whether or not they contain the diagram. Now, apart from my interest in the diagrams in and of themselves, I've wondered whether they could provide me with a tool for establishing the relationships of the quite substantial number of extant manuscripts. Following in the footsteps of Dominique Reynaud, who has published the first ever stemma codicum based on geometrical diagrams instead of text, such diagrams that you see on the top right on the slide, I have tried to address this question. He claims that the best diagrams for studying the phylogeny of a manuscript tradition are 3-dimensional representations that are complicated enough to have a minimum of 50 susceptible loci to scribal errors. So therefore, the diagrams of brain ventricles are indeed, they are indeed representations of a 3-dimensional complex structure, but they do not contain sufficient susceptible loci inviting scribal errors. And applying the core principles of stemmatology to my diagrams also yields the same result. Now, I contended that the shape, number, and configuration of the diagrams can potentially be the source of indicative errors. So, like, I had to answer this question of, like, if I want to, like, create a stemma codicum, what could be indicative errors? So the core principles of stemmatology demand that for an error or variant to be indicative or significant, it has to not only be unique, but also irreversible. The latter meaning that the scribe must not have been able to easily correct the error. Now, in the case of brain ventricle diagrams, shape cannot be indicative, in my opinion, because it's not necessarily unique. The majority of the diagrams are drawn using basic geometric shapes, which are characteristic of the visual culture, the general visual culture of the Islamicate tradition. And next, both number and configuration are reversible. That is, a scribe seeing a diagram with 3 ventricles in the manuscript they were copying could check this data against the text, which explicitly says that there are 4 ventricles, 2 in the front, 2 in the front. So the scribe can perhaps correct the diagram in the process of copying. Therefore, none of these elements provided by these diagrams can be unique and irreversible in order to be indicative variants or errors, as demanded by the principles of stematology. So suffice it to say, such humble diagrams cannot be the material for constructing a reliable stemma codicum representing the familial relationship of the manuscript witnesses. Still, I argue that there is value in thinking in terms of family tree metaphor in the case of these modest diagrams. These diagrams can still prove very useful in grouping the manuscripts and establishing their relations in specific cases. So we cannot be systematic, but in specific cases, they can prove very efficient, as I will try to show. Now, to give some order to this chaos, I've assorted 24 diagrams in this table and chronologically ordered those that are dated, which span from 431 AH, so that is like 11th century, to the 18th century of the Common Era. Those diagrams that are found in undated manuscripts, I have placed in between those that are dated based on visual affinity. So that is the table that you see on the slide. Now, I want to share some observations regarding the diagrams at hand in this table to further elucidate the value in looking into them in the frame of family tree metaphor. So, in the Arabic manuscript witnesses, I would suggest that there is no single correct tradition. There is visual confusion since very early in the tradition. The diagram in the oldest manuscript, that is number 1, is partially smudged, but even despite that, one can see that the visual representation is in no way depicting the Galenic idea expounded in the text. Diagram number 2 seems to be an attempt at visually recreating number 1, or perhaps a common ancestor. Numbers 5 to 9 must be further attempts at visually recreating their ancestor, regardless of the information provided by the text, as in none of these diagrams, that is 1, 2, and 5 to 9, the 4 supposed ventricles are in any way discernible. Diagrams 3 and 4 clearly belong to the same family. Both are most accurately depicting the 4 ventricles using curved lines within a square box, perhaps representing the entirety of the brain. Then manuscript containing number 10 is quite valuable, as it contains one accurate diagram in its text block, that is 10A, while there's another accurate diagram in its margin, that is 10B. And right above, so in the manuscript itself, right above the diagram in the margin, there is a collation note that confirms that this manuscript must have been collated with another manuscript containing an equally accurate diagram. Now, the cluster 13 to 22, except 19, seem to represent an established visual semantics. Now, I would argue that this coherent visual representation does not necessarily mean that numbers 13 to 22, again, except 19, are all members of the same family and the descendants of one and the same ancestor. Rather, it could be the case that this manner of visual representation was more familiar to the later scribes, possibly due to the higher number of the available copies of the work, or the general encyclopedic knowledge of the scribes in these later centuries. Now, a margin diagram with a different ink in the earliest manuscript, namely 1B, shows significant visual affinity to diagram 19 being found in a quite late manuscript. I will come back to this. Now, while diagram 23A could have been an innovation, stripping the diagram to a most minimalistic representation and 24 relying on it, the margin diagram 23b might be looking back to the cluster 13 to 22 for an improvement in visual representation. And with this, I hope I have kind of like given you some sort of clarity in this like visual chaos that I exposed you to at the beginning of my talk. Now, moving to the indirect witnesses. Drawing on the work of Dr. Sivan Gottlieb on the Hebrew and Latin translations of this text, I want to share some suggestions, mere suggestions, regarding transmission paths of the manuscript witnesses of this work, based on both visual affinity and the collection the manuscript witnesses have ended up. And in doing so, I do hope that I will give you one more reason why it is of value to look at such diagrams in terms of family tree metaphor. Now, both of these unfortunately shaped diagrams on the top show up in dated manuscripts, one as a marginal note on a very early manuscript and another in a very late manuscript. Now, the Hebrew tradition, the instance witness on the right, seems to rely on an Arabic witness that is now lost, I would suggest, on which both manuscripts on the left rely on. Going to the Latin tradition, the visually nonsensical, I want to say, Latin tradition seen on the right seems to rely on a line of transmission via Spain, which draws on one of the most accurate depictions of the ventricles of the brain. That was like diagram 3, now held in Tehran. So, as to the question or the issue of representation and use of digital tools, I have more questions than answers, but I still want to share them with you. The text of this work has shown up in print in modern times. I will not get into details, but like the first one is the Koning's 1903 diplomatic edition based on Paris manuscripts, and the second one is the Kuwait edition of 1987 based on 4 witnesses. But you see on the slide how the previous editors have chosen to deal with the diagram in a print edition. But in a future critical edition encompassing a manuscript edition of like 80-something witnesses, the editor shall have to answer the question whether they would represent in the lemma an anatomically true representation or a codicologically true one, which would require comprehensive stomatological study of the diagram, so not just the text itself. So a digital edition perhaps could have like support more direct linking between text and diagram or between different diagrams. The digital file, so like the SVG, for example, could support color coding to highlight these different ventricles as represented in different manuscripts, so on and so forth. So in short, digital tools perhaps at some point be opening new doors in this regard. And before I move on to conclusions, I want to very briefly underline 2 instances that suggest a mutual give and take between text and image, text and paratext. One is the interpolation we have already seen on the left. Now I want to remind you and stress that in this short note containing anatomical knowledge deemed crucial for the reader of philosophy to have regarding the brain was described as being cone-shaped. Now, could this visual representation of the ventricular system of the brain using the figure of cone have shaped the very conceptualization of the brain and found its way back into its textual description? I mean, that's just a question for now. The second instance shows up in a manuscript in Majlis Library in Tehran listed as al-Mansuri, but in fact, it's Kefayat Mansuri. It's a Persian work by the 14th century Persian medical author Mansur ibn Ilyas Shirazi. Interestingly, so this is a very random finding that I had, just because this work was ascribed to al-Rāzī. So in a subchapter dedicated to the anatomy of the brain, we read that, I'm reading the English translation, the shape of the brain is a conical triangle. Its base is the front of the head, and it is softer than the back, as it is the growth place of the sensory nerves, and the cone's vertex is the back of the brain, and it is hard, and it is the source for the motor nerves, so on and so forth. Now, I have never come across a mention of the brain being cone-shaped or triangular in any preceding text. So images we have seen, but text I have not come across. Now, this begs the question, have the diagrams of the ventricles been metonymically transferred to mentally visualize or conceptualize the brain with this novel representation using such shapes as cone, triangle, or shapes in between, finding its way back into texts? Now, of course, at this stage, this is just a speculation from my side, but in any case, the study of anatomical diagrams, no matter how humble they look, can be an apt practice in probing into the dynamics of text and paratext, text and image. To move to conclusions, regarding the elaborate illustration in the Istanbul manuscript, it is clear that apart from the crossing of the optic nerve and an attempt at illustrating the layers of the eyes, this illustration is not strictly a realistic representation of the anatomical structures in line with what we today would expect from an anatomical illustration. However, the elements clearly delineated in the illustration bear witness to enduring visual traditions. The fact that the ventricles of the brain are not represented as delineated structures reflects a lack of visual tradition for depiction of the ventricles of the brain. That is to say, so this elaborate representation that we see in al-Mansuri does not catch on in the Islamicate tradition by future illustrators. This illustration is a very carefully planned one. And the presence of the explicatory sentence both in the text panel and the illustration frame suggests a careful supervision of the author in the process of the preparation of the archetype now lost to us. Furthermore, it is one of the very rare instances in the Arabic tradition that the idea of ventricular localization of the faculties of the soul is represented in a primarily visual medium. The comfort of the illustrator with impossible perspectives might make us uncomfortable. But by overcoming this initial discomfort and allowing the image to speak for itself, we find a wealth of knowledge contained in it in accordance with its own inner logic. Moving to the mini diagrams and the witnesses of al-Mansuri fi Tib, although a clearly delineated stemma codicum is not possible to construct based on exclusive reliance on such small diagrams as the ventricles of the brain, I hope I've managed to show that these diagrams still provide one with efficient tools in comparison with the text for discriminating between and grouping the manuscript witnesses containing them. And applying the principles of stemmatology to these elements that occupy a place between text and image provides one with valuable food for thought regarding the dynamics between the two. So I would leave you with this, I guess. I would like to draw on the words of a colleague, Charlotte Cooper Davis, who has a very valuable work on medieval paratext. And she has this phrase that calls on us to look into such diagrams and study them in their full paratextual glory. And with that, I thank you for your time and attention.